The last type of word problem we're going to look at for this particular worksheet is going to take us right back to percent problems. So we talked a little bit about percent problems in the previous worksheet, so they're back, all right? So for this topic, it's problem solving involving price reductions or increases. Now, this does not necessarily have to involve a price. So when you're dealing with reductions or increases involving percents, again, it doesn't have to involve price. Frequently it will. So for these examples, I do have this involving very specifically price. Okay, so steps to solve a direct translation problem involving percent. And it's not just involving percent, specifically where we're dealing with like a discount or a price increase or something. So again, doesn't have to be price. For these examples, it will be. So assign the variable to the original value. So we're going to have some original value. We're not going to know what it is. We assign the variable to what we don't know, the original value. The equation should follow the form, the original value or the original price, plus or minus some percent of the original price. Now that plus or minus symbol, you'll see it in different ways. In this case, I just mean you're either going to do plus or you're separately going to do minus. And it all depends on if you're dealing with some kind of reduction, like a discount, or some kind of increase, like a markup in price. Okay. So you're going to take the original price plus or minus some percent of the original price. So we're going to take the percent, whatever this percent is, and multiply it by the original price, which is going to be our variable. And that's going to equal some new quantity, some new value, some new price. Okay. So you're always going to follow this equation. Again, this plus or minus just means you're either adding or you're subtracting depending on the nature of the problem. Okay, so for example 7, it says solve each problem, include an equation and units with the final answer. You need to understand you're in an algebra class. You have to show us the algebra. That's what we're really grading you on. Okay, so part A, it says a sweater discounted by 65% for an end of year clearance sale has a price tag of $33.80. What was the sweater's original price? So we know the discounted value. The discounted price is $33.80. What we're interested in is what did the sweater cost before it was marked down? Okay, so we're going to let X equal the original price. Okay, so we know we're going to take the original price and we're going to subtract the discount. Anytime you're dealing with a discount, that's a price reduction, so it's going to be subtract. So we're going to take the original price, whatever that is, X, we're going to subtract 65% of X. So when you're dealing with a discount, it's always going to be some percentage of the original price. So we want to write 65% as a decimal. So remember, you move your decimal to the left twice, so we get 0.65, but it's 65% of the original price. So we want to take 65% times X and then subtract that from X. And that's going to equal some new value, which is going to be the sale price, which we know to be $33.80. Okay, so we were able to follow the model that we have laid out at the top of the screen. So the original price, we called it X, plus or minus in this case, some percentage of the original price, and that's going to equal the new quantity, the new value, or in this case, the new price. Okay, so what we want to do is we want to combine like terms. I have two terms on the left that both contain an X. Now, we don't generally write it, but remember, this is really just one X. So what I need to do to combine like terms here is I need to take 1 and I need to subtract 0.65. So literally just the number 1 minus 0.65. So we get 0.35, and it's 0.35 times X, okay? And that's going to equal $33.80. Okay, so this 0.35x represents the value of the original that we're still paying for. So we got 65% knocked off. We're still paying for 35% of this sweater. Okay, now I want to get the x alone. The issue is x is being multiplied by 0.35. So I need to divide both sides of this equation by 0.35. On the left, 0.35 divided by 0.35 is just 1. 1 times x is just x. And then 3380 divided by 0.35 is, you're going to get some crazy number. Actually, let me show you so you can see here, because we're going to have to do some rounding. So we have a calculator here, and we want to take the price, which is 3380. That's the discounted price. Remember, we were dividing both sides of this equation by 0.35, so we want to divide by 0.35. and we get this mess. Now, we're dealing with money. Money always has two decimal places. So unless you're dealing with money and they very specifically say round to the nearest dollar or something, you're always going to round two decimal places. So we have 96.5714 blah, blah, blah. Well, we're really interested in that 7. That 7 is what we're either rounding up or down. So we have 0.57. We look one digit to the right of that, which is a 1. That 1 is less than 5, so it tells me to round down, which means the 7 stays alone, and then everything after that, you just chop it off. So we're going to say that this is approximately $96.57. You know, there was a teeny tiny bit of wiggle room, but that's what it's ultimately going to be. So the sweater was originally $96.57. Now it's $33.80. Okay, so this is the original price of the sweater. And there we have it. All right, so let's look at part B. So for part B, it says the cost of a room at a hotel is $160.45, including 7% tax. So that $160.45 already includes the tax. Okay, how much was the cost of the room before the tax was added? So this is a very similar situation. We have the cost of the room. We're going to call it X. We're going to let X equal cost before tax. But this time, since we're adding tax to it, we're going to add some we're going to add some percentage of the original price. So I don't want to subtract here, I want to add. And I want to add 7% of the original cost of the room. So when you're dealing with percentages, tax, for example, sales tax, when you have sales tax, it's some percentage of the goods that you're purchasing. So in this case, the good is a night in this room. So you're going to pay 7% of that cost in addition to the cost of the room. So 7%, we would write as 0.07 times the original cost of the room is X. So this right here is your tax. And that's going to equal the total of the room plus the tax, which is 160.45. So again, we need to combine like terms. Don't forget we have 1x plus 0.07x. So 1 plus 0.07 is 1.07x. That equals 160.45. And then in order to get the x alone, we have to divide by the coefficient of x. We have to undo that multiplication of 1.07 and x. So we divide both sides by 1.07. Well, on the left, 1.07 divided by itself is 1. 1 times x is x. And then just using your calculator, let's go ahead and use the calculator here. We have 160.45 divided by 1.07, which is, again, we're going to have to round. So we're going to go two decimal places. So we've got the 149 and then 0.953. Those are the three digits after the decimal we're interested in. So looking at the 5, directly to the right of that is a 3. That 3 tells me to round down. That means the 5 stays the same, and I chop everything after the 5 off. So let's go back to here. Whoops. There we go. So we would say again, let me do it on this one because I forgot what it was already. 149. So we get that the cost of the room is 149.95 before tax. So that's how much the room is before the tax is added to it. Okay, so we've done a lot with problem solving. We talked just intro to direct translation. We learned how to write equations and expressions. We learned how to do just really basic problem solving where it's kind of like anything goes. We talked very specifically about consecutive integers. We talked about solving problems involving perimeter. And now we've talked about price markup or price markdown. So discounts, price increases, what have you. So we've done quite a bit. There's more to come. So next worksheet, we'll have some more situations involved.